Hi, this is Mr. Mack. This is the concept video for solving inequalities. First of all, if you have two real numbers, A and B, we say that the greater of the two numbers is the one that's the farther to the right on the number line. So as I've illustrated it here, A would be less than B. Now, the inequality sign, less than, greater than, less than or equal to, greater than or equal to, are the four signs, symbols that we usually use and call inequalities. Now, it turns out that when we have an equation, we have certain ways of solving an equation to get an answer, and we use things like the addition property of equality and the multiplication property of equality. Well, now with inequalities, it works pretty much the same way. If we know that A is less than B, then if there's some distance C, and let's just postulate this as a distance for C, if there's some distance C, then if we were to take that distance and add it to A and add it to B, then the new places that we'd have on the number line would be A plus C and B plus C. Now you can see that if we add the same distance to both A and B, then A plus C is still to the left of B plus C. Now this illustrates the addition property of inequality. In other words, if you have an inequality, if A is less than B, then A plus C will be less than B plus C. Now notice, if we were to subtract the distance C from B, then we would get here A minus C, and here would be B minus C. Now notice A minus C would be less than B minus C. So this first one we would call the addition property of inequality, and the second one we might call the subtraction property of inequality. Basically what these two say is that if you have an inequality, it's okay to add or subtract the same thing from both sides of the inequality. The inequality will stay in effect, or will stay in imbalance, if you will. Now, no, that's not working. Let's try this. Now, if you have A is less than B, and you want to multiply both sides of the inequality by a number, there's a consideration that has to be made. Let's just pick numbers like 2 and 5. Now notice on the number line, here's 2, here's 5. Notice that 2 is less than 5. Now, if you multiply both sides of this inequality by a positive number, say 3, for example, you'll get 6 and 15. Now notice, 6 is still less than 15. Whenever you multiply both sides of an inequality by a positive number, the inequality sign is preserved. Now let's go back to 2 and 5 again. If we have 2 and 5, we know 2 is less than 5, and let's imagine that we want to multiply both sides of this inequality by -1. Now that would give us -2 and -5. Now, Let's take a look at -2 and -5 on the number line. Well, -2 would be about here, and -5 would be about there. Now, which of the numbers is less? Well, it's pretty obvious that -5 is to the left of -2, so it would be the smaller of the two numbers. Now notice, when we multiplied both sides of the inequality by a negative number, the inequality sign changed directions. This is the multiplication property of inequality. Now, since division is just multiplying by the inverse, division works the same way. If you have an inequality and you wish to divide both sides of the inequality by a positive number, then the inequality sign is preserved. If you divide both sides of an inequality by a negative number, the inequality sign is changed. So that's something that you have to remember. Now, other than that, solving inequalities works just like solving equations. The one thing you need to remember is that if you come to the point where the step you want to take is to multiply or divide both sides by a negative number, then the inequality sign changes directions. Now, one more thing we do want to talk about is graphing solutions of inequalities. So let's take a look for just a minute at an inequality. If we say x is less than 2, think about this with me for just a minute. See, what we want to do, if we're going to graph the solution, is we want to show on this number line all the numbers that make x less than 2 true. Now, it's obvious that 2 doesn't make x less than 2 true, because we get 2 is less than 2, and that's not true. But the question comes up, what is the first number to the left of 2 that does make it true? Well, the truth is, all the numbers to the left of 2 make x less than 2 true. And it's impossible to tell what that last number is. So what we do, instead of identifying the first number that does work, we put an open circle around 2 to identify the last number that doesn't work. This open circle signifies that we're going to go up 2, but not include 2. And then what we'll do is we'll shade in on the number line in the direction that we need to go. See, in other words, if x is less than 2, then we want all the numbers to the left of 2. Now, if we have x is greater than or equal to 2, or x is less than or equal to 2, then on the number line, we would include 2. Now, the way we show that is we fill in the circle. Now, still, less than works, so we would shade in this particular direction, and then we would eventually color in an arrow over here. So basically, when you have an inequality, if you have the equal to sign, then the circle on the number is closed in, and when you don't have the equal sign, the circle on the number is not closed in. Now, one other thing that's important about graphing is you need to identify this endpoint. Sometimes the endpoint is already identified. For example, if we have x is less than 2 or x is less than or equal to 2, and we put the mark at 2, 2 is already labeled there. But if we had something like x is greater than 1/2, and then you have the number line -1, 0, 1, 2, you would want to put in, say, a mark here for 1/2. When you put a mark in like that, it is not right to expect the reader to assume what that particular line means. So you need to label that line. In other words, if you put a line in other than a grid point, label what that line is. Now, we would put an open circle around that, and since x is greater than 1/2, we would shade this way. But you will not get full credit unless you actually show what that point is when you put a point in between the grid points on the number line. Now, a lot of times also we want to give the solution sets to these inequalities. So if we have an inequality and it turns out that the solution set is all the real numbers less than 2, a lot of times what we do to show that set is we'll use what is called set builder notation. It looks something like this. See, this is a left set brace. Sometimes I like to call this left mustachio. And what we'll do a lot of times is we'll put right inside there a variable and then either a colon or a straight up or down line. And that is read as such that, and then we put the restriction on it here. For example, x is less than 2. Now this would be read the set of all x such that x is less than 2. And that's set builder notation. That's something that's covered, and so I wanted to include that. And that takes care of this particular section. We're done.